Welcome to the AOS-CX 10.14 update series. I am Shobana, TME for HP Aruba Networking. The application recognition fast mode feature is a topic of interest in this video. Since its introduction in the CX portfolio with the 10.11 release, the application recognition capability has served as the foundation for various enhanced security, threat intelligence, and visibility features. With the 10.14 release, we can now switch the application recognition mode to fast to further enhance its performance. During this session, let's get more details about it. Here is the usual agenda we will be following for the TOS session. The list of acronyms that will be used in this session is presented here. Overview. So let's recap the principles of application recognition, also known as application recognition and control, we can call as ERC in short, before we continue. An application-aware access network can be established with the use of application recognition functionality. It identifies the network applications using deep packet inspection and manages them according to our configurations. So it gives administrators access to the statistics and application visibility. On-device L7 visibility is obtained by ERC, allowing the network administrator to monitor which applications have highest traffic exchange, monitor applications and then the application categories as defined by the DPA engine when the clients are accessing them. And we can also view the connection establishment statistics. Next is the IPFix integration. Attach the application identifier information and data into the IPFix export record. The application information obtained from ERC along with the flow statistics is exported to the IPFix collectors. Finally, we have the application-based policy enforcement. It controls the applications accessed by different users connected to the switch. It leverages application recognition as well. So this ARC feature can be enabled on a port level or the user role level. App ID is associated to all 5 tuple flows and we support around 3800 applications with this feature. Hence, there is no doubt it is part of CX Advanced Feature Pack and it is supported in CX 6300 and 6400 V2 platforms. If we do not receive the application recognition journey details, our TOS session will be incomplete. So this slide provides an overview of the application recognition features journey inside our CX portfolio. The 10.11,000 version established the basis for our CX portfolio's application recognition capability, which could set the app ID in the IP flow table and it can be enabled in the ports or roles. Next comes the application-based policy. It expands the capabilities of application recognition for the AOS-CX policy engine, supported in LUR, DUR and device profile roles. The permit and drop action was covered in phase 1 of the implementation in 10.12 version, and while the mirror, priority and remark actions were handled in the phase 2, that is in 10.13 release. So latest in the line is the support for application recognition fast mode feature. It uses FPC to identify the application with less packets and supports app name, app category and then description for an application flow. So far we have seen the introduction about the fast mode. So let's see the difference between the default mode and then the non-default mode, that is fast mode, introduced as part of 10.14 release. So prior to 10.14 release we had only the default mode, and in the default mode the application name and category are gleaned via the FPC and system will process more packets to extract the URL and then the TLS attributes of the application flow. On the other hand, fast mode also relies on FPC to glean the application name and category and description only. So it doesn't process more packets for the additional attributes. When it comes to the benefits, default mode helps us to extract the TLS attributes, whereas Fast mode helps us in increasing the performance. That is, we could achieve improved connections per second up to 25% increase in the CPS compared to the default mode. As a reminder, the fast mode is supported from 10.14 release in CX 6300 and 6400 V2 switches. Let's understand the use cases. The application recognition fast mode offers the same use cases as default mode, but with additional benefit of improved connections per second. Here is a brief summary of the use cases for application recognition. Foremost is a distributed DPI for application recognition at the access. So the applications can now be recognized locally on the access switches rather than requiring the centralized entities like gateway, SD-WAN router or the firewall for the application recognition. So the next thing would be application visibility and reporting inside the campus. So the application recognition provides on-device L7 visibility which can be reported to internal as well as external collectors. Last but not least, foundation for application-based traffic control and QoS. It controls the applications accessed by various users connected to the switch using application-based policy enforcement. Difference between something good and something great is attention to detail. On the same lines, let's jump into the details of this feature. So let's understand the internals of the operational modes present in the application recognition feature. The application recognition feature relies on the DPI engine to recognize the application that a flow carries and to extract other flow attributes including the TLS headers. So the number of packets of each flow that the DPI engine has analyzed determines how many flow attributes can be extracted. Therefore, if a user simply wants the necessary information such as application name and application category, we can reduce the amount of packets that need to be processed for a flow by relying on the first packet classification, where it extracts only those necessary information from the first packet itself. The switch can handle more flows and hence increase the flows per second scale when the number of packets that must be processed for each flow decreases. To support this behavior, we have two operational modes present in application recognition feature. Foremost and the newest as part of 10.14 release is the fast mode. The DPA engine uses the FPC to identify the application in the fast mode. Once the application has been identified, it stops processing more packets. The FPS scale rises in this mode because fewer packets must be processed for each flow. The next and the default one is the default mode. The switch will analyze further packets to extract other flow attributes such as URL and then the TLS information after extracting the application name and then the application category if feasible using the FVC. So when the switch is in this mode as opposed to the fast mode, the FPS scale will be reduced since the switch processes more packets per flow. So let's understand the DPA process using this slide. So let me give the introduction of the main entities that I'll be using in this slide. Foremost will be the PC connected to the access switch and application recognition will be enabled in the client connected port. The other main entities are the IP flow table, CPU, DPA engine and then the FPC cache. So let's understand the DPA process in a step-by-step procedure. So I'll be using a TCP handshake between the client and then the application server for explaining this DPA process. So the PC1 after DNS resolution starts TCP traffic to the application server. So the ASIC forwards the packet to the destination and there is no software forwarding involved in this step. So the next step will be due to following factors like flow lookup miss in the ASIC, miss in the FPC cache, and then application recognition enabled on the ingress port. And since it is a unicast TCP or UDP packet, the packet will be copied to the line card CPU or the VSF member CPU for DPI processing. So in fast mode, the DPI engine will need to examine only the initial few packets around 2 in both ingress and then the egress directions before identifying the application ID. As a result of this, a 5-tuple IP flow entry is created in the IP flow table with all the other information except the app ID. Because it's not yet recognized, only after the recognition the application ID will be filled here. So the packet copy is sent to the DPA engine agent, which is executing on the main CPU of the standalone 6300 or the one core of the LC CPU or the VSF member CPU. Similarly, from the server side, the TCP SYN ASIC is forwarded to the client by the ASIC. There is no software forwarding involved here. And the process repeats, like the first egress packet is copied to the line card CPU or the VSF member CPU for DPA processing because of the above mentioned conditions are not met. So it is same as the ingress packet. This time it is a egress packet. Similarly, for the egress flow, there is a 5-tuple flow integrated in the IP flow table with the empty application ID, since the application ID is not yet recognized. A copy of the SYN ASIC packet is sent to the DPA engine for examination along with few more return packets until the application ID is recognized. The TCP acknowledgement from the client is received here. So until the application ID is recognized, this packet will be forwarded to the DPA as well, and so on for the next few ingress and then egress packets of the application recognition enabled port. So the final two steps are really crucial. So the app ID of the ingress and then the egress flows in the IP flow table is set by the DPA engine upon recognition of the application. So following the application recognition, the DPA engine will cache the destination IP, destination port, and app ID in the FPC cache, ensuring that further flows are first verified against the FPC cache, and the packet will only be processed by the DPA engine in the fast mode if there is a miss in the FPC cache. So any further packets are coming in the same application flow, it will be first checked with the FPC cache. If there is a match in the FPC cache, it will be utilized rather than forwarding all the packets to the DPA engine for processing. As you can see here, the ordering and then the time sequencing remains the same with respect to both these modes. The only difference is the number of packets required for the DPA processing. So in case of default mode, it will use around 6 ingress packets or 5 egress packets to identify the application ID as well as the other application attributes like URL and then the TLS. But in case of fast mode, it will take around 2 packets, both ingress and egress, for the DPA processing until the application ID is recognized. So the difference here would be around only 50 ms for the toe sequencing between these two modes. Let's see the difference between the default mode and then the fast mode using the flow table dump. So we have used the same application for this testing. The application used here is Amazon. When you see the dump of the float table for the default mode, we can get the URL details of the application being used. But in case of fast mode, we will be able to only get the application ID. The application URL will not be present. Here is the list of some of the widely used applications classified as FPC and non-FPC as per the protocol bundle version used in our CX switches. So how do we know and identify if an application is FPC or non-FPC? So let's understand in this slide. If an application is catchable in the Cosmos protocol bundle, it will be categorized as a FPC supported. So let's now examine how the Cosmos will designate the application as catchable. Applications are considered as catchable if they can be stored in our FPC cache table using trusted data that is present in the initial first packet itself from these applications, such as server IP address and then the port information. So any flows from these applications in the future can therefore be compared to the previously classified entries in the FPC cache, thereby simplifying the task of identifying applications. Hence, these applications are classified as catchable. Here is the list of caveats to be noted on for this feature. foremost will be the additional attributes in the flow record. So the user should not configure additional flow attributes in the flow record such as URL, DNS reason code and TLS attributes, as these attributes will not be collected in the fast mode. Next thing would be the when the applications are running behind a proxy. So when the applications are running behind the proxy, the FPC will not be operational as the destination port will remain the same. Also, DPA engine will need more packets to determine the application as the destination port remains the same. This also results in FPS scale increase because the FPC will not be operational and then there won't be any entries in the cache table to identify the application's new flows. So it is really important to understand these two caveats with respect to this feature. Configuration. Here is the configuration option enabled in 10.14 for this feature. So under the application recognition context, we have the new CLI sub option called mode, and it will have two options. One is the default mode and the other one will be the fast mode. And here is a snippet to help us to configure the fast mode. So inside the application recognition context, you can change the mode as fast. Next comes the REST API to enable the fast mode. So under the system app recognition context, we can enable the mode as fast using the REST API call as well. So with respect to show commands, let's see the show commands of ARC feature first. So we can use the show app recognition show command to verify the current operational mode. And next will be the show tech ARC. Even show tech ARC will display the current operational mode of the application recognition. So the next set of show command will be the IP flow show command. So we can use the show IP flows to view the IP flows recognized using the application recognition feature. So with this IP flows show command, we can see the application ID, application name, and then the application category. And here is a list of best practices to be followed for this feature. The first point to be noted down is use default mode if your deployment is looking for additional flow attributes from the application like URL and TLS, because these attributes are not supported in the fast mode. The next point to be noted is the application recognition scale limits are based on the flow table size, and flow table size is per LC or the VSF member. Hence, it is advisable to distribute the client across the line cards and VSF member to reduce the probability of exiting the flow table size. Troubleshooting. Let's see the list of steps to be followed for troubleshooting any issues with respect to this feature. The foremost step to be followed with respect to troubleshooting is the show commands. Here is the list of show command to view the current operating mode of ARC. So we can do show app recognition and it has an option to display the current operational mode. Similarly, we can use the show tech to view the ARC current operating mode. Apart from the CLI show commands, we can also use the REST API to fetch the current operating mode of app recognition. You can perform the get of system app recognition to identify the current operating mode of ARC. The next thing will be debugging. So we have a dedicated debugging module for the ARC, that is debug ARC. So using this ARC debug, we can debug any issues with respect to the application recognition feature. Apart from ARC related show commands and debugs, we can also perform the diagram of flow tracking to identify the list of flows and then the corresponding application identities identified using the ARC feature. For this demo, I'll be using a 6410 V2 chassis. My client is a Windows laptop connected to the Access LC 131 port, and my uplink is connected to the Core LC 1412 port, and the web proxy address is 1082.217. Here is the minimum configuration required for the demo. As a prerequisite, you can enable the flow tracking, and then application recognition has to be enabled with mode as fast, and I have enabled the application recognition on the client connected port. So you can use the show IP flow show command to see the list of applications, their corresponding ID, name and category. First, let's check the show run application recognition. The first prerequisite is flow tracking enablement, and then we have enable application recognition mode as fast, and then application recognition is being enabled on the client connected port 1/3/1. The next prerequisite will be the feature pack installation, and it is running in the honor mode. So let's run the show run interface for the client connected port. So I have enabled the VLAN, and then the application recognition is also enabled. So let's check the show IP flows output. Currently the interface is disabled, so there is no flows reported. Similarly, we can use the diagram flow tracking basic to identify the flow dump. So both the show commands and diagram are showing empty, reason being is the port is disabled. Now let us enable the port and run some of the applications in it. So we'll go to the client laptop, and then we'll start the Microsoft Store. So it will run some of the applications in background. So you can check the applications are started. Simultaneously, I will try to open a Chrome window and then open some of the widely used applications like YouTube, Twitch, and then LinkedIn. So we have started those applications. Let's check the application flows in the show IP flows output. So we can see the application name and then category listed in the IP flows table. So now we'll use the diagram output to view the flow table. So the diagram output will display the client MAC address and then the list of applications source IP and then the destination IP. Along with that, we can identify the application ID. Since we are running in the fast mode, the application URL, those are additional attributes and will not be displayed in the diagram output. So we can only view the application name and then the application category in the fast mode. So far we have seen about fast mode. So let's now switch to the default mode. So I am trying to change the mode as default from the application recognition CLI context, and then we'll use the show app recognition to view the configuration change. And it clearly states the operation mode has been changed to default. So I'll be using the same client connected port for the default mode as well, and will run the similar applications. So let's go back to the client connected window. So I'll be running the same applications here as well to show the difference between the fast mode and then the default mode. Microsoft Store has been opened, and in the browser I am starting the YouTube, Twitch, and then social networking platform, LinkedIn. So now let's go back to the switch console and check the IP flow table output. Show IP flows. So it will display the flow information. So all the application which we have started in the client is now displayed in the show IP flows along with the source and destination IP of those applications, and then the main application name and then the application category. So let's view the diagram output of IP flow table. So if you could see here, the diagram output clearly shows the application URL as well. So previously in fast mode it was not available, but in case of default mode we'll be processing additional packets to identify the application URL as well. Let's hear about the scalability and performance of this feature. So for this feature, the scale limits are applicable per LC or BSF member. So we have done the comparison for the scale results in both the modes, when it is default and then the fast mode. The first few rows list the flow table sizes, and then the maximum flows supported for both the modes. So here is the 6300 and 6400 V2 switches, max flows, max bidirectional flows, and then max PPS scale limits. So all these are per LC or per PSF member. So the main thing to be noted here is the connections per second achieved using the default and then the fast mode. So when it comes to default mode, we could achieve 500 connections per second. But with fast mode, we have a enhanced performance and we could achieve 625 connections per second. So that is a 25% increase compared to the default mode. So for this testing, we have used a mix of FPC and non-FPC applications. So overall, you would see a 25% increase in performance because of the fast mode. Everyone for watching this video. If you have any further queries on this topic, you can reach out to our team PDL. Bye.